Hey, welcome back to part 3. So in the previous video, we went through how we can set up our boilerplate with Springboot, and we were successful to create a simple application that returns hello world. So this was what we got previously, and if you make a call to hello, in this case, then we are able to get back a response. So I will have to do nvm springboot run to spin up this application on port 8080 first. And over here, we're able to set it up on our localhost port 8080, this application, this backend application. And if we use Insomnia to make a request to this server, we're able to get back hello Boban. So even though it's really simple, even though it's just a few lines of code, implicitly we are already creating our own controller. And this application, this class over here, is serving as our controller. We also define a view layer, and specifically this view layer only consists of one function or method thus far. So a method is a function under a class. So this is what we got. And we were able to direct all requests to localhost hello to this route over here. So that's pretty much it. So as we discussed, for today, we'll be building on top of our existing view layer. Specifically, we'll be creating the view splitter service. And this is really application logic already. So it's not really Springboot per se, I would say. It's more on creating our own single class where it has a single responsibility of splitting the price of a list of items given a list of users. And for each of these users, we will calculate the price that they have to pay for each of them. So that's about it. So let's get started. So before we dive into it, let's recap like how the view splitter service would look like. It would support a single method called splitView. It will receive a list of output users, and the output users, in this case, it will receive a list of input users, input items and input users over here. My bad. And the input items is this class over here. The input item consists of a name attribute of type string, a price attribute of type double, and a quantity attribute of type integer. So the name represents the name of the item, the price is the price for every single item, and the quantity represents the number of items that we bought for this. On top of that, we also have input user. So for the input user, it only has a single attribute, which is the name. And to recap, in this case, even though in reality, we would have users with different names, for the sake of this simple project, because we are hoping to focus on just understanding Springboot, we would simplify this design by using the name as the primary key. So what this means is we will expect all names that is passed to us as unique names. And given this list of input items and input users, what we are going to do is to calculate the the amount of money that each user is going to pay, and that is encapsulated inside our data class output user. So output user is this class over here. It has a name attribute name, it has a double of total, a total attribute of type double because it is in cents, like we have dollars and cents, and this total represents the total amount of money that this user will pay. Of course, our users will have trust issues, so they would also want to know why exactly they have to pay that total. So it would help to also return an attribute items, which represents a list of output items. So this output item data class is our second output data class. It has 4 attributes. The first is the name of the item. The second is the price for every single item, as well as the quantity of this item that we have bought thus far. On top of that, we also have the people who have split this list of items with. And finally, we also have slim users in this case. And this slim user is a user that is inside this output item over here. So the people who are contributing to this output item will be here as well. So let's take a look at the input item thing over here. Okay, let's see. Perhaps we have to change the function signature a little bit, because currently if we receive this, it's possible for this list of items over here to be unevenly split across these users. So it's possible that for some of these items it's only split among maybe 3 people, but maybe for another item in this list is only split within 2 people. So perhaps this function signature should be revised such that inside this input item over here, it also represents the people that we are splitting this with. So let's take a look over here. So currently this is the input. So let's change it a little bit perhaps. Let's move these users to be inside these items as well. And this way, we know exactly for each of these items who exactly are they splitting with. So what I mean is we can shift this and move it inside this dictionary over here. So let me quickly edit this. And what this means is that our data models would change just a little bit, specifically for our input. So something like this. We are moving the users to the top level. So inside the same data model as the inputs. So as the items, sorry. So the items layer over here would be like this. So we will still have this input user over here, but inside our input item, we would have users and we have a list of them. Okay, so pardon my handwriting, but this will be a list of users. Okay, so it's a little messy now, but I'll correct that in a bit. So what this also means is that our build splitter service would not take in these input users, because these input users would be nested, would already be available inside the items over here. So let's remove this, and that's about it, just like this. And our items here, these input items, would already contain a list of users that are contributing to each of these items. And let's vet our output model as well. Yeah, that looks fine. That looks great. Okay, so that's about it. So with that, we can get started with the build splitter service. So let's continue. The first thing that I'm going to do is to try to separate the responsibility of the controller from this build splitter application. This build splitter application has the single responsibility of being the entry point for our Springboot application. And in the previous video, we made the REST controller, we made this build splitter application class have an additional responsibility of being the controller. So that's not great. So what we're going to do is we're going to create another class, and let's call this the build splitter controller, and let's make this a separate Java class. So I'm going to split this to the right so that you can see both. And what we're going to do is we're going to shift this. We're going to shift this view method into this separate controller. And of course, we would be shifting the annotation to this class instead as well, so that the responsibility of this controller is shifted here. I'll be removing the, oh nice, we already have this. So the imports for the controllers are here as well, and I deleted them away from the application. So just like this, we should we should be able to separate the controller away from the application. Let me rename this. I'm a little pedantic, but yeah, just so that we make every single word in this class capital case naming with the capital case naming convention. So now that we have this, we can build this again, build this project again. Okay, so continuing path. It's okay. I think I'll leave it to Maven to build this project instead. So let me run this. And the beautiful thing about this is, notice that we didn't have to change the code for the application. Specifically, we didn't specify anywhere here exactly where the controller is. And that's because Spring Boot uses these annotations to identify where the controller is. So there's no need for us to explicitly define, like tell Build Splitter application where the controller is. So now we have our server running on port 8080, and my current hypothesis that we are able to separate our controller into a separate class, and that Spring Boot should be smart to notice that this is the controller. And to validate that, what I'm going to do is to make a request to hello over here. And if this works, this validates our hypothesis. So let's make a request, and there we go, hello Boban. And just to be sure, I'm also going to change the code here just so that we're sure that Maven has registered our changes. So we should see hello to you, Boban. So let's spin this application up again. This application is now running on port 8080, and let's make another request. Hello to you, Boban. So this validates our hypothesis and also reconfirms that Maven has registered our changes. And that's great. So we are successful in splitting our controller to a separate class. And with that, we can get started with the data models for our Build Splitter application. So now what I'm going to do is I'm going to create a package, and I'm going to call this models, and I'm going to place all of the models inside this folder. So to make it clearer, I guess I'm going to put these two files side by side so that you can see how the data looks like as we build the data models. So the first data model is the input item. This input item will be provided by our user. So let's call this input item. Let's call this input item, and there we go. And now we can define our attributes. So the first is the name, the second is the price. Okay, in this case, let's just make it public. A public name, a public price, and public quantity. Okay, so integer quantity, and public user. And this will be a list, a list of users, input users, like this. So we are missing the user as well. So let's create the user. So let's put user class like this, and let's define the single attribute name. Okay, so some of the smart parrots might notice, hey, like I noticed that in other projects they tend to define these attributes as private, and they set getters and setters. So why are you not doing the same? Well, in this case, we are not doing any validation for, like usually it's helpful to have getters and setters if you wish to have some validation logic before setting something. Or maybe perhaps you want users you want to do some pre-processing or some checks before users can get an attribute. But in this case, for the sake of this project, there's really no validation logic for name, price, quantity, and users. So defining these attributes as public is more than sufficient in this case. So I'm just going to go with the simplest approach of making these attributes public. So now that we have these attributes, we haven't defined the constructor. So let's define the constructor. Okay, in my experience, I remember from some of my talented colleagues and friends that Java has their helper annotations that allow us to automatically edit a class to have an automatic constructor generated with getters and setters. But for this video, I'm just gonna build these data models the vanilla way. So I'm just gonna define this constructor here to set the attributes ourselves. So this constructor will take in a name. Okay, I think in this case I can expand this so that you can see the code better. So we have a double price, we have an integer quantity, and we have a list of users. So list of input user. I guess it's better for me to be clear that I want this to be an array list. So I'm just going to use an array list instead. So to our viewers, the list is an interface. So, and the list over here can be implemented in many ways. It could be a linked list, it could be an array list, it could be other types of lists. So in this case, we want to keep it simple and just make it a dynamic linear list. So I'm just going to use the array list as a type for users over here. So array list users, and there we go. And now what we're going to do is we're just going to set the name, the price, the quantity, and the users. And that's about it. So now let's do the same for the input user as well. So public input user, we are setting up the constructor. So this dot name is the name. And there we go. We have set up our data models for our input. So now let's take a look at the output models. So for the output models, we have name, total, and a list of items. And we have an output item, name, price, quantity, and people, or rather users, I guess. Yeah, so let's do this. So some of our smart parrots might notice that, hey, the input and the output model looks the same. Like, why not just make them the same model? I mean, it's up to you. It's quite subjective. But personally, for me, I would like to separate the input and the output models so that by any chance, if we wish to add in some additional fields to the output models, it will not affect the schema for the input models. So that's why I am separating them. So on following that chain of thought, I would be creating 3 separate classes for these 3 data models over here. So once again, since we need some reference, I'll be creating output user. Okay, now we have the name, the double, and we have array list of output item, and we're going to call these items. Of course, it's going to complain because we haven't created the output item. So let's create the nested class output item. Okay, there we go. And now let's do string name, double price, integer quantity, and we have the array list of slim user. Let's call these people, or rather, I guess let's call these let's just call these output user for the sake of like we have an input user, so let's just call this output user. So let's call these users. And there we go. Let's import this from Java util. And now let's create our constructor as well. So public output item, string name, double price, integer quantity, and array list, output user, users. This dot name equals to name, this dot price equals to price, this dot quantity equals to quantity, and this dot users equals to users. Yep. So let's do the same for this output user as well. Let's define a constructor, public user, string name, double total, array list, put item, items, and this dot name equals to name, this dot total equals to total, this dot items equals to items. And now we have the user and the item. And let's see, output item, output user. Okay, let's see. For the output user, I have a list of items, and for this, we have, oh, we need a slim user. So we need a slim output user, I guess. Slim output user. And this slim output user only contains the name attribute. So over here, I made a mistake. I set this to be output user, but the output item is really a class under the output user over here. So this should not be using this. This should be using slim output user. And slim output user is a user that only contains the name. So let's create this. So string name equals to this dot name equals to name. Yep. And that's about it. So we have defined our data models over here. And of course, each of these data models are not used yet, but we'll be using them in a bit. And we are going to use them exactly by creating a service. So let's create another package called service. And this service represents like classes that do a single thing. And now what we're going to do is we're going to create a build splitter service. And like its name suggests, it has a single responsibility. The responsibility take in a list of an array list of input items, returns an array list of output user. So output user over here represents the total price, the total amount of money that each user is going to pay. And we're going to calculate that based on the list of items. So i.e. splits the bill across users. So that's about it. For this bill splitter service, we do not have any attributes, or rather any dependencies. So in this case, I'm going to skip creating the constructor. The constructor is typically used to set up the service. So for example, if you had a database connector, that can be a data access object as a class over here, like class data access object something. And in the constructor, you would set up the connection to your database. That would be a dependency that your data access object need. But in this case, for the bill splitter service, it's fortunately not involving any I/O. So we are just going to create a simple public, a simple static method. So over here, it's going to return back an array list of output user, and we are going to call this method according to our schematic to split the bill. So it's going to split the bill, and it's going to take in an array list of input items. So items, and that's pretty much it. This is our bill splitter service. So now we will be moving to implement this bill splitter service. So let's take a look at the data again. So let's expand this. Okay. So the logic of splitting the bill is fortunately pretty straightforward. What we're going to do is we're going to iterate through these items here. And to calculate the price, the total price for this item, we're going to take the price and multiply it by the quantity. So if you have 10 bottles of cola, then you would have, then this would be $20. So but with this $20, we are going to split this $20 and assign it to each of these users over here. And your next question might be, you smart parrots will probably ask, hey, so how do you keep track of the price that each user will pay? We can use a simple hash map to keep track of the amount of money that each user is going to pay. As we mentioned, the assumption was that every name is going to be unique in this case for just this practice. So what we're going to do is we're just going to take this price and we're going to divide it by the number of users, or rather the size of the array list over here. And this price would be split across each of these users, and we will use that to update our hash map. So we will do this logic for every single item inside here, and we will end up with a hash map where the key is the name and the value is the price that each person have to pay. Using this hash map, we're able to reconstruct this total over here. The name would just be the name of the user in the hash map. The total would just be the value of the hash map. And the items over here are interesting. Now we have to keep track of the items that each user have to pay for now. So what this means is we also have to create perhaps a separate, perhaps a hash map also needs to keep track of this item's information over here as well. So okay, we can have a hash map of users, and it can map to a list of input items that they are contributing to. And then we can do the aggregation to calculate the total, and we would have the value of the hash map, which contains the list of items, to be here inside here. So that's a lot of words. I think it's probably a little hard to follow with just the explanation. So let's code it out and we will see if that works. So let's create a simple hash map, and this hash map would be a string to an array list of input items. And this, in this case, let's call this user to items, and this will be new hash map string array list input item, like this. So get or default. If the key doesn't exist, then we would just return back a simple new array list of input items. Okay, let's see. Let's take a look at this function signature and see how does this get or default work. So let's see. This takes in a key and this gives back a default value. So, oh, I think, is it default value? How do we, oh, I guess you can use get or default instead of setting the default behavior on the constructor. I'm pretty sure there is a way to set it. So let's set default behavior, default value on hash map constructor. Ah, okay, interesting. Ah, okay, I guess we have to define the default. I guess we have to define the default when we are getting a value. I'm surprised that they don't have it. I'm pretty sure they must have it, but okay. But it's okay. Let's use get or default then, if that's the case. So let's not set the default here. And okay, with that, we can start populating these users to items. So for this array for each output user in this for each input item that we are going to iterate inside these items. This item over here would be this list of items that we want to split the bill with. So let's get the list of users. So for user in item.users, okay, let's see. We are going to use this input user over here. So let's call this user. Okay. For each of this user, append the current item into the user to items hash map. So let's do user to items dot set. Thing is it put? Yes, it's put. And in this case, we are going to use the user name as the key, and we are going to put the, let's see, user to item. We put this. How do we? Okay, so perhaps we should get the current hash map first. Sorry, the current array list from the user first. So current array list of input item current user items is equals to user to items dot get or default user name. And if the current users to item hash map doesn't have anything, then we are going to return an array list of input item, and that is empty. Okay, place with, okay, why is this complaining? Contents of collections array list input item are updated but never queried. Okay, I guess that will be fixed after we do this. So we will be adding this item that we have into this current array list, and we will be updating it here. So that's pretty much it. Okay, for each of the user, okay, I guess I should leave some documentations here. So this hash map key is the user's name, and the value is the array list of items this user is contributing to. So for each of the items, each of the input items, we are updating we are appending the item to each users to items array list. This lets us keep track of which items each is contributing to. Okay, so now at this point we have the hash map that contains the users to items. So perhaps this is one responsibility. Perhaps we should abstract this to a separate method so that this method would just be responsible for keeping track of which item each user is contributing to. So let's define a private static array list. Oh, sorry, let's call this a hash map of string array list input item get user items. Okay, so this user to item method over here, we're taking the array list of input item. And this represents the items that are sent to us by the Telegram chatbot. So let's paste it here, and over here we are going to return this user to items hash map over here. And just like this, we can also get the hash map that we calculated inside this split bill method by calling this method that we just defined over here. So let's do bill splitter get user to items, and we'll pass in items, and there we are. We have abstracted the complicated logic of keeping track of which item each user is paying for into its own separate method over here. And now we can perhaps define a second method that uses this hash map to reconstruct the array list, of output user. So that sounds great. So let's call this private static array list of output user. Let's call this get output users, and this method would use the same hash map containing each user's list of items they are paying for, and with respect to this we can get an array list of output user. So now for let's see, for is entry set, I guess, is the entry map of string to array list of input item. How do we iterate through a hash map again? So let me check iterating a hash map in Java. Let's see. If I'm mistaken, we can use iterators. So yes, just like this. So we can iterate through the entry map.entry set, and this would give us back a key and a value. And if we want to get the key or get the value, we can call the getKey method on the entry object over here. So looks great. Let's do that. So let's do entry map.entry, and let's import this from Java util. And over here we have user to items. Let's call this users to items. And now if we want to get the user name, so string user name, this would be user to items dot get key. And if we want the array list of input item, then this would just be user items equals to user to items get value. Okay, so why is this complaining? Variable users to items may not have been in. Oh yes, of course, I forgot to iterate this. I forgot to pass the hash map here. So let's call this hash map user to items. Oh, sorry, users to items with a plural, but it's probably a little confusing because these two variables are very similar to each other. So I'm going to call this single user to items. Sorry for that, bear with me. So now we have single user to items and we are iterating this. Why is this complaining? For each is not applicable to hard Java hash map entry set. I guess I should have called entry set instead. This entry set method over here returns back a set of keys and values. So yeah, that looks great. So now that we have these usernames and user items, we can calculate the total that this user have to pay for. And the reason why we have to calculate that is because we're returning it over here as the as the total over here. So to do that, we have to sum up the price for each of these items. So for input item in user items, okay, so let's calculate the current price. So double current item price equals to item dot price multiplied by item dot quantity. So as we discussed, like this price and quantity over here. Okay, let me see. Yeah, did I make a mistake here? I think I made a mistake here. This is supposed to represent the price of a single item, not all the items. But the total item price, I should call this total item price. So total item price represents the product of price and quantity. So this will be used to calculate how much each user have to pay for. So let's get the thinking about it, we will also need to keep track of how much each person have to pay for as well, right? So this is going to be, we will also need a hash map. In this case, this would be a string to a double, and this would call user to total. So this would be new hash map string double, and that's about it. So this will represent users payable. So now that we have this total item price, we also have to divide it by the users that are contributing to it as well. So let's call this integer users contributing, and this is equals to let's see, item dot users. And because it's an array list, we can use size. We can use the method size on it to get. Okay, I guess for the sake of readability, I'm just going to separate these to a variable. So let's call these item contributors. Okay, so array list. Let's call this input user item contributors equals to item dot users. And what we are doing is we are doing item contributors dot size. And so what this means is that the current user. Okay, so for each of the users, for input user in user item contributors, we will update this hash map with each of them. So this would be users to total. Okay, let's see, users items, users items. Actually, no, we are already iterating through each of the users over here, right? So just bear with me. We are iterating through all users in the hash map. Okay, so for each of the user list of items we have for each user, we calculate the price the user has to pay and update it into the hash map. Okay, so perhaps we do not need to have this hash map over here because we're already iterating through every single user and every single item has already been arranged into an array list for each user. So there's no need for this actually. So perhaps all we need to have is a high level double. Let's call this total payable to user, and let's set this to be 0.0, and we'll be updating this as we go. So now we have the user contributing and the total item price. So what this means is that the current user payable item payable to user this represents the price the user needs to pay for this item. This will be equals to the total price divided by users contributing. And that's it. And now that we have this, we will add this to item payable to user. Yep. Okay, so why is this complaining? Type may be primitive, wrap it to primitive. Okay, I guess that's fine. Okay, let's just make this a simple primitive. And now we have the total payable to user after going through the list of items. So for each item a user is contributing to, calculate the price the user has to pay. So that's about it. So now we can construct our output user. So output user goes to new output user, and this output user here has a couple of parameters. He has 3. So he has the name, total, and item. So let's pass in the name. The name in this case would be username, and the total is total payable to user. And finally, the items over here represents the list of items this user is contributing to. So we will pass in user items here, and there we go. So now that we have this current user items, okay, it's complaining. Why? Okay, it needs an output item. Do I have to cast this? Okay, I'm going to create a nice little method under output item so that I can convert an input item to an output item. I guess you can call it a smart constructor. So let's take in an output item, and over here we're going to take in an input item, and this is a separate overloaded constructor. Takes in another input item and constructs an output item. So let's do this dot name equals to input item dot name, and we have a this dot let's see, price equals to, see, we have an input item here, we have the price here, and in this case it's going to be this dot price. This dot quantity equals to this dot quantity, and this dot users is equals to this dot user. Okay, so input item has a list of users as well, but that contains input user. Okay, and this is, oh, sorry. Yeah, I made a mistake here. Input item equals to price, input item dot quantity, and input item dot users. But this will fail because we need a slim output user. So we need a smart constructor for slim output user as well. So let's create another one. Slim output user, and this would take in an input user, and this would be this dot name equals to input user dot name, and that's it. Now we can use this constructor. So slim output user, and we are going to pass in this input items of users. So looks like I have to do this. So array list of slim output user, let's call this list of users equals to new array list of slim output user. Okay, and for each of this input user in input item dot users, we are going to create an output a slim output user by calling the smart constructor that we just defined, and this will be using the input user to construct this output user instead. And now that we have this output user, we can add this to the array list that we just created over here, and we will set this to our output items users as well. So converts an input item into an output item. Okay, that's about it. So now that we have this smart constructor, we can use it inside the build splitter to convert each of these users items into an output item. So now let's see this. Okay, this and this. Okay, output items. So let's see array list of input items. Okay, I guess we'll have to convert these to an output item as well. So array list of an output item, output user items equals to new array list. And what we're going to do is we're going to iterate each of these user items and convert them into an output item. So we're going to do that right here. So for output item for input item. Okay, for input item, user items. Actually, we are already iterating it here, right? So let's avoid iterating it twice. And what we're going to do is we're going to take advantage of this for loop as well to add it here. So we're going to do new output item. It's the new output item, and we're going to use the smart constructor we created on the output item to convert this input item into an output item like this. So we are invoking this smart constructor over here. So now that we have this, we can add this into our output items array list. And now we can pass in our output user items into our current output user. And we have successfully created, calculated the amount of money current output user has to pay for. Okay, so there we are. And now what we're going to do is we're going to add this into an array list. So let's call this array list of output user. Let's call this output users. And this calculate represents the users that we calculated their bill for. So this would be a new array list of output user. Okay, and now we can add this calculated output user into this list over here. And at this point, we can return these output users. Okay, so there we are. We have created a method that is able to take in a hash map of users to the items that they are paying for, and we calculate the total amount of money that they have to pay for, and we append it into an array list. So let's use this method now inside our overall split bill method over here. So let's call this array list of output user. This would be output users equals to bill splitter service, and we're going to call this method that we just defined. So it's this one, and we're going to pass in the user to items, and there we go. And at this point, we can return the output users that we just calculated over here. And that's it. So local variable, okay, I mean, I could inline it. Yeah, sure. Okay, and that's it. So we are done with the bill splitter service. And the last thing we're going to do is to, okay, I noticed that I made some errors, did I? Oh yes, I did. I forgot to put round brackets somewhere for the constructor over here. Okay, let's see, where did I make that mistake? Oh, there we are on line 37. I forgot to call the round brackets for the constructor. So there we are. We got our bill splitter service. And now we can use that inside our controller over here. So let's create a separate routes. Let's get mapping. Let's call this split bill. And let's call this public array list of output user. And the request parameter would be value equals to items. And let's port this. And we are not going to define a default. We will expect our users to provide it to us. So this would be, oh sorry, this would take in an input user. And this would be items. And we're going to use the bill splitter service. So return bill splitter service dot split bill. And we're going to pass in the items that is received from the user. So let's see, it's complaining about something. Let me see why exactly is it complaining. So split bill returns back an array list of output users. And oh yes, input items, right? So it's not input user, it's supposed to be input item. Yes, I provided the wrong input model. Yes, this input item represents this high level items that we receive from the client. And this would be unexpected token. Okay, is it complaining because I made a syntactical error somewhere? See, not request parameter not applicable to field. Let's see. Oh, it must be a string, is it? Oh, I see. You have to pass it yourself. Okay. So this has to be a string, right? So we have to do some casting. So we have to do some deserialization of this string into an array list of output users. So let's call this an array list of input item. Input equals to new array list of input item, and we are going to pass it into this split bill for now. So return outside method. Okay, let's call this an array list of output user. Output equals to bill splitter service, and we return output. So why is this complaining? Oh, sorry, array list. Is it because we forgot to define a name for this method? Ah, that's why, split bill. Nice, so now this works. But it looks like this request parameter annotation here takes in a string. So it's hard to believe that Springboot would not have a way to take in an input model and perform the deserialization for us. So I think we're missing something. There must be a way. Considering Springboot is really mature, my intuition tells me that they should have a way to deserialize the input from the user into our input data models. So for example, like other frameworks would also have that feature as well. But if that is not, if that's not possible, it's fine. We can also do that ourselves. So let's define, let's check the documentation if they have input parameters. So Springboot input param. Oh, sorry, is it request param? Yes, it's request param. Let's check request param, and there we are. So we have request params here. Interesting. So you can use options or strings, but I don't see. Oh, nice. I didn't know that request parameters allow a map as well. So, okay. In short, it seems that we have to do our own validation. So Springboot request param input data model. So I guess there is additional work to be done. To be specific, it seems that we have to define our own deserialization logic. So to our smart parrots out there, deserialization logic is where we convert raw data such as strings into an input data model. So unfortunately, in this case, it seems that we probably will be using this. We will probably be using this map of strings to values, and we will be converting each of these keys and values to their respective types, representing the input model that we defined. So for what it's worth, we are done with the bill splitter service. So the last thing we are going to do is going to wrap up the deserialization logic so that we can pass that into our bill splitter service and we can test it out on Insomnia. So that was pretty decent. We have came somewhere. To our viewers, if you notice that some of the implementation logic is a little fuzzy to you, I'm so sorry. In this case, we can be easily lost in the implementation. But in summary, we have defined two methods. The first method is to arrange each of these items by users, such that if an item is contributed by a user, we will put it in an array list dedicated to them. We place this array list inside the value of a hash map, and the key is the name itself, so that it's easier for us to further split the bill for each of these users in the next step. In the next step specifically is this method get output user, and what we do is that for each of these array lists of items for each user, we calculate the price that this user has to pay, and we wrap it and encapsulate that calculated amount into the output user over here. And we use these two methods that we define to define a higher level method called split bill that calculates the array list of users as well as the price that they have to pay. And what we do afterwards is we place this inside the controller over here. We define a new route, and over here this is incomplete. Unfortunately, we are not able to get the deserialization logic down in this video, but I'll be continuing that in the subsequent video. And that's it for today, and I'll see you soon in the next video.